Hello everybody, welcome back to From Rhythm to Algorithm. We continue on with our derivation. So now what we've kind of demonstrated in the last 4 or 5 episodes is the logical bounds produced by physics. So mathematics is way down here, then language, then logic, then order. And order and chronology kind of produce the environment and what has been stabilized physically. That's what we talked about last time. Magnetism being stabilized charge. We have this fundamental dynamic of two things. So now we've categorized the ordinality, the unique pairings of what could a number represent. So now we live in a world where we can say one notebook, one light bulb, one camera, an order of magnitude. And so we can kind of just start by stating the complete basis of geometry, right? One what? One thing. Well, what can that thing, what's the most simplistic thing that can be represented by one, right? A point. What's the most simple thing that can be represented by two, right? 2 points. The difference between 2 points is one line. That's really the basis of all geometry, right? Numerically, 2 is, we had this quote unquote special number, but it's the only number that satisfies n plus n equals n to the nth power, right? 2 squared equals 4, 2 plus 2 equals 4. And then all other numbers, again, that aren't rational, aren't really uniquely pairable to, the universal phase changes are what are uniquely paired to numbers. And then within this bounding of, we have the stabilized 2, and then we have cardinality, we have magnitude. That is where you get natural opposition. So we've discussed at length now the difference between inversion and opposition, which again, I thought I explained it well. But that is 2 points and the difference is a line is the complete basis of geometry, right? Because 2 has to be something and 1 has to be something. So if you have 2 points, between those 2 points you have a line. And subsequently, or continuing on, the first closed shape you have is 3 points and 3 lines. And so more overall, again, we've derived and proven I think that's the Collatz conjecture, but whatever, the one a to the n plus b to the n equals c to the n doesn't have any solutions past 2 because there's no physical stabilized dynamics. There are no physical things that could be represented in that form. And so more generally, we can say again, n to the n plus 1 maps all n. But now we've proven this uniqueness of the fundamental stability of 2, so the only dynamic that really makes sense is the stabilized 2 and then this open dynamic, which we call dimension 3. We live in 3 dimensions. And so the logic there is intuitive, or it's not exactly correct, but it's plenty fine enough where once I've walked you up until that point, it makes plenty fine just again to say we live in 3 dimensions. But that is the complete statement of what geometry could represent. Because again, logically and physically, we've bounded mathematics. And so 1, 2, 3 has to be one thing, 2 things, 3 things. Numbers have to represent physical systems. And so charging separates, censoring separates. So now again, we're contracting all of these, the things that I've put in green, those are huge chunks of proofs, and these proofs are, again, contracting. Everything's getting closer, everything's cooling down, so things are getting smaller or more condensed. But logically, we're condensing all of our logic with these proofs. So these proofs do huge logical reductions. But again, before we've conjectured that sensorality is filtration, but we're just continuing on. Charging separates, like when we talked about last episode, you charge your phone, you're creating potential, and then censoring separates, right? And so we're trying to find this logical basis to show the linguistic differentiation. And we're getting close. Separation is disparity. Sensorality is disparity again. Or I just have separation is disparity, then sensorality is disparity. Sensorality spares. Sensorality is despair. Sensorality is sparality. Despair is destitute. So again, some of these I could still put on the screen in terms of like disparity, that is like parity, P-A-R-I-T-Y, and then despair, P-A-I-R. So again, I can continue to show you some of the spellings, but I haven't been editing them because again, we're going to get to a point where just sensorality is, and then intuitively, again, from the physics, it will be obvious and it will axiomatize sensorality. But we have sensorality is destitution. Despair is destitute. Destitute, distribute. Charging is the opposite of stabilizing, right? Stability minimizes movement, right? Again, that just should speak for itself. It should be overwhelmingly physically obvious, right? You can have something sitting on a, unstable equilibrium, a ball on top of a hill. It gets perturbed a little bit, it gets poked, and it's going to fall down the hill. It's stable, but it's not, in a potential that it's going to minimize movement. So stable equilibrium is exclusively when you have a trough and like a ball at the bottom. And so that's a big kind of thing that arises in Newtonian mechanics. But we've derived stability, again, from the fundamental, literally the things you're looking at when you're interacting with objects. And then again, when you're charging something, when you're separating charge, it's the opposite of stabilizing. You're creating potential, you're creating tension, and that tension is going to tend to stability. It's going to try to reach equilibrium. Stability produces property. There's two positive, negative, and I want to say spinning, but spinning extremely, extremely tightly, and it's not physically breakable, then you get a magnet. And so anything he says property, it comes from physical stabilization. Property, properly. And then again, the difference between those words is the L and the T with a little line through it. Properly is right. All right, if you do something correctly or properly, it is right, R-I-G-H-T. So that's still lurking there, that huge L-I-T-E versus L-I-G-H-T and R-I-G-H-T versus R-I-T-E. Because like even when I use like personal emails, if I say constitutional rights, I still spell it R-I-G-H-T, and it's definitively wrong. I just try to avoid that if I'm dealing with somebody on a personal level, they're like, oh, this guy is illiterate and retarded. And I'm like, hey, Johnny, go watch, me derive all of science. It's like, that's not going to happen. And so it's so weird. You get to a point where it's like, you literally have to say the wrong thing so the stupid people don't have problems go off. But that's a huge something is going on with that. Sensorality is properality. And so now when going from property to properly, and then adding the ality, we've derived the ality. It's kind of hard for you to discern that, but it's true. And so sensorality is properality with an emphasis on the ality. Sensorality is plurality. Sensorality is operality. Operality operates. Obvious natural definition. Operates, sensorates. Operality functions. Fun, function. How does fun function? Operation, then function. What is a function to an operation? Functions contain operations. And so, right, because we have this chronology. That's the biggest thing. Again, opposition exists because of this fundamental stability of two physically. And then we have inversion, which we walked you through. There are, again, the infinitesimality to infinitesimality has literally never been identified in mathematics, and it's a well-defined operative analytical tool thing, part of mathematics everywhere, all of the time. And so, but we have this chronology, and in understanding what inversion really is, when you can't have the opposite of mass doesn't exist. And so those are two, like I said, the two biggest mathematical things that are not really understood. Inversion and where natural opposition comes from. But we have chronology. And so what comes first, an operation or a function? Fx equals x squared plus x plus 2. I don't know. But you have a variable in there. It can stand, but again, we've physically bounded variation, what a variable can represent. And then operations do something to something else. 1 plus 2. You're adding one thing to two things. And so functions execute, operations are executions, right? Right. The x squared plus x, the addition, that's the operation. The totality is the function. But is there any type of exclusivity? Does operation come first? Again, physically. Or does function come first, or does it even make sense? But operation is well defined, function is well defined. How do operations function? How do functions operate? Proper is classy. Sensorality is classy. Proper, prosper. Sensorality prospers. Sensorality is prosperity. Sensorality is spiritality. Now here's a natural derivation that's very poignant as well. But because we've derived now inverse, right? When people say something to the effect of this is proportional to this or this is inversely proportional to that, right? It's some sort of limit. And so because we have our speed limit, right? Infinity is well defined, but we have transmission limits of what information can be. The speed of light, which is really a propagation limit. Radiation propagates, right? Proper, propagate. And so proportion, but we've derived the logic as to why people say the inverse of this. And then typically the exact imagery, it's not imagery, but the conceptualization that you'll pull to mind is, flipping a fraction, right? And you can't have zero, right? And that's why you can't divide by zero, because it doesn't represent anything. And so you have natural inversion, but it's really a limit because you don't have no thing, right? And that's what nothing is literally. and so, right, like the maximum limit, the ratio of infinity to the ratio of infinitesimality is like the bounding of transmission. Literally just trying to do it off the top of my head, but what the propagation limit, the speed of light, but that's why you also see the speed of light, then it's gravitational waves. It's a propagation limit of radiation. Something moves and that causes information to be put into the world. How fast can that information move? And so the infinitesimality again is how so again, why is the bounding of the physical, why is it always progressive operators? Again, we went through the addition being slower than multiplication, multiplication being slower than exponentiation, but why do you always, when someone says do subtraction, you really add a negative number. Do division, you really multiply by a fraction, by the reciprocal. So inversion produces reciprocality, but point being is this infinitesimality, right? It's like the limit of things growing as slow as possible. And what's growing? Entropy, right? The amount of energy. No system is perfectly efficient, so all movement produces entropy. And so we started with that beginning of the Big Bang, or the stabilization of R2, as much entropy as possible, or as little entropy as possible, and then movement creating a disorder. And so rhythm limits that, and the maximum limit would be vibration, right? You zero movement, which isn't possible because of geometry. And so the infinitesimality limit, again, is physically paired to entropy, the entropy increasing. That is what you're really modeling. And so that's why everything has to increase. That's why you're modeling functions, again, addition, multiplication, exponentiation, and then the inverse, the reciprocals, division, subtraction, rooting. Again, I still don't really know what the uniterating, whatever, doesn't really matter, but it's paired to entropy increasing. And then the slowest entropy could be increasing is physically maximizing rhythm, so movement is as efficient as possible. You can't have zero entropy increased. So you never reach, physical perfection in terms of maximal movement. No perpetual motion machines exist. And so it's really that's kind of like why. If you took up, again, 1 over 1, then 1/2, then 1/3, and then you just keep making that fraction smaller and smaller, you're still getting bigger, but you're getting bigger at a smaller rate. And it's all coming from, again, physical processes, and that physical process being the evolution of entropy. And so, yeah, but back to these, temperature is inversely proportional to stability. I just made a little short video about it, but right, if something's really hot, things aren't stable. They jiggle around more. But so again, as we've seen throughout this derivation, things will arise naturally where this is proportional to this, and this is inversely proportional to this. So that does happen. It's not always in the positive, sometimes in the negative. They're logically equivalent, but on a personal level or on a scientific level, why does that occur? I'm not really sure, but again, just pouring out any insight that I can provide. And so when you say inversely proportional to something, right? If PV equals nRT, if temperature's increasing, pressure's increasing. If pressure's increasing, temperature's increasing. But these inverse proportionalities are, again, this product of opposition. And so, but this we've derived, right? So this is a logical step of why you say this is inversely proportional to this. And so we're really producing, again, the entirety of logical structure, which is way, way past just like mathematics. It's anything that comes from order, which is everything. But proportional versus inversely proportional is dichotomistic, right? There's only two options. If you have two things that are related, it either can increase or decrease. Again, another trivial facet of this fundamental stability of two. And so another trivial thing that pops up, fraction. And so we've derived the physical basis of what a fraction can represent. And a trivial physical demonstration is when glass or ice breaks, right? Those jagged lines, why does that happen? Because everything's discrete, and it's discrete at the atomic level. So trivial physical demonstration, but we've provided the logic. And now we can just simply state this applies to that physical system. And now we're trying to produce this new word form. And so I had another, again, kind of brief intuition. We've covered ordinality and cardinality as much as possible. But we're bounded in this. We have this like lower limit of fundamental stability of two physically. There's nothing that you can interact with that doesn't have two physical components. That property is charge. But, all right, we have this structure, one, two, many. And so, right, that's like the stabilization of cardinality, and cardinality is derived from ordinality. We have these universal phase changes; those pair uniquely to ordinality, first, second, third, and then fourth. We've derived that whole thing completely. There's nothing else to say about that. But cardinality is magnitude, and so you can write first to second, right? Those being, again, the phase changes. The actual phase change, again, is the moment of zero entropy. And so you can write that out uniquely. It's super trivial, again, with words. But I literally just have the word first and a little arrow, and there's a 1 underneath that, and the word second, and another little arrow, and then the word third. But point being is that is where you get those phase changes. That's where you get one too many, the stabilization events. First, second, and third being the ordinality, the physical change of order of the whole universe. And then the vast majority of all mathematics is in cardinality or in magnitude. And so many, magnitude. But we stated the complete geometric basis. Is that all I want to say for here? Yeah. And so that's really it. Again, some more logical stuff. Again, like the logical poignancy. People just don't even... And I guess that's kind of like the end of the derivation for right now, but it's so true where it's like, I call it logical lying. And it's not actually lying because I don't lie. Certainly not in like fundamental science, but what I mean is, at this point, if you're one of the people that are actually watching this derivation, you see how quickly all of this logic progresses. And there's, like I said, I'm limited by that progression physically, not me. Like, I have a supercomputer, it's ready to go whenever. But when I'm talking about logical lying is, I could say 1 + 1 = 2, you can follow it. I can say 1 + 3 = 4, you can follow it. These I don't even like to say upper again, but these completely logical steps, you can't really see like why it's true all of the time. And so effectively I could say logically, 1 + 1 = -6,432. And you would, put this in air quotes if you're just listening, but believe it. And what I mean is, not even like you believe me or you're trying to be a yes man, but you've seen so much logical consistency that you don't have the basis to say yes or no, and you feel what's going on is intuitive, but you're not really sure what the fuck's going on. And there's tremendous swaths of that. So for what it's worth, I don't conjecture, believe it or not. Like, I don't say things that aren't directly known. Which is probably virtually imperceptible to everybody else. But The point being is I'm pushing you up to the logical boundaries as best as possible, but this irreducibility facet is still overwhelmingly present. And so you can't reduce words past their fundamental intuitive meaning that's stabilized outside of me. I learn the same words you've learned. I live in the same environment you do. So you just have to build these big intuitive structures. And by doing so, again, we're piecing together the word sensorality, again, word by word. So I guess we can finish up there with the actual derivation, right? We're getting to the point where sensorality, right? Sensory, sensorality. And so clearly, again, we have to get this sensorality as our range, our noun, our conceptualization, and then we have to derive it down to sensory. And then again, some form of that word is still right in between there. And that pair, again, it's essential, right? Essential, that's what we've kind of... But the linguistics, well, again, we've already done the whole linguistics derivation. But to this, again, to this upper level of logical presentation, it's just, I've never even like interacted with somebody that's like capable of, again, this is the best example is if somebody were like, again, to tell you 1 + 1 = 3, you would definitely, like, I mean, there's no chance you wouldn't be like, that's wrong. But again, not in like an emotional way, not in like you're respecting or not respecting that person, it's just objectively wrong. Objectively, other people don't have enough logical development to see what could be or what could not be objectively right or wrong. So I effectively never conjecture, ever. But that is what I have for you on derivation today. Just the pure statement, and it's complete, right? One could not represent anything else more simplistic geometrically than a point. Two could not represent anything more simplistically than 2 points. And the difference between those 2 points is always a line. And so that's a complete derivation of the basis of geometry. Like, geometry will never be more simple than that. What could one thing be? What could two things be? And then we live in an environment with many things. And so there might be some more refinement between cardinality and ordinality. Like, again, there's no unique word for one as a denominator, but first, second, and third, and then 1/2, 1/3 kind of still gives me some intuition, but I'm exhausting all of the light bulb moments. Last episode, again, light and thinking are both resistance. Like, literally, that's why you say a bright idea or, a light bulb moment. And so when you personally, whoever's watching this video, when you have personal realizations, that is what I'm describing in proper ontology, and there's nothing else to like realize. And so like collectively. And so my rights continue to be violated. I'm providing you as much insight as possible because this is like the meat, I guess, of the development. Because it's like when you finish these, when you get to this like completion demonstration, you're just hitting all of these fundamental things all day, every day. But again, I want to emphasize that all these other steps, obviously, I mean, they're obviously not trivial by any means, but they're not more or less poignant for me. I can just tell when I get on YouTube and see like this person's talking about this and you guys are talking about this. It's like, these are the parts of mathematics you have never seen before. And so I'm trying to provide you as much insight as I can when we go through them. Because we're in the nitty-gritty specifics. Because remember, conceptually, we're not really saying that much anything different or anything controversial even. We're just demonstrating how language develops. And all of these facets are already empirically present in the words you use every single day to describe anything logical, anything structured to make sense. You do all of these things intuitively or just explicitly describing them. So that's what I have for you tonight. Thank you for watching, and I'll see you on the next one.